Alright guys, so in this video, welcome to Blue Tech Empire Python tutorials, and in this video we are going to look on how to install the Anaconda distribution. I believe it's called the distribution because it comes with a couple of other programs. Anaconda itself comes with a couple of other softwares or IDs. It tries to integrate them in one way or the other. So Anaconda distribution actually comes with stuff like Jupyter Lab, you have Jupyter Notebook, you have Gravis, and you have Visual Studio Code. Sometimes, I don't know, but most times you have R Studio, you have Orange and Spider. Even most times you would see PyCharm within Anaconda. So it's called a distribution because it actually distributes these programs or IDs or softwares or environments, and it tries to integrate them in one way or the other. So let's get into the video now. Okay, now I want you to understand Anaconda does not depend on the Python installation on your computer. Why? Because Anaconda comes with its own Python installation. In fact, Anaconda installs Python on your computer, but it actually installs Python within its own directories. You can even configure your computer to use the Python distributed by or installed by Anaconda. And last time I checked, it looks Anaconda installed something like, I think, Python 3.8. But we have a video on how to install Python separately. So if you haven't watched the video, you can watch the video before watching this. If you want to install Python without Anaconda, you can check the pop-up on the top right hand side, and you can get it there. So that's how to install Python without Anaconda. But if you like to use Anaconda, particularly because Anaconda is used mostly for data science, data analysis, and some other stuffs, but mostly when in relation to data. And Anaconda is also used for teaching because it contains Jupyter, and Jupyter is very conducive for teaching. If you want to teach, or you want to create Python notes, that's why it's called a notebook, because you can put text as well as code in Jupyter. We are going to be looking at Jupyter specifically, and we are going to see how we can do some data science examples along with some normal Python programming examples like Python codes, and I'm going to show you how to work with Jupyter Notebook. So let's get to the web to try to find Anaconda. So like I said, everything you want you can get on Google. So we're going to check Anaconda. I think there's Eclipse. No, we want Anaconda download. So it's simple. This is Anaconda for Windows. All right, installation. I think here we don't want docs. I think we want Anaconda from here. All right, so this takes us to the Anaconda. As you can see, the website Anaconda products, individual. Maybe you can even go to Anaconda products. Like, so here is it. You can always search and come to this place. Now note, Anaconda, you can install it on Mac OS, on Linux, on Windows. So now I'm going to be showing you guys Windows. Like I told you, 64 bits, and it comes with Python 3.8. This time 64-bit, it needs a 64-bit operating system. And like I've said in previous videos, if you want to check the operating system architecture, you can go directly to either any folder, and you go to this PC, and you go to properties, and you're going to find it here. You see I have 64-bit. It all deals with the memory, how the memory addressing of the computer, how programs save, and when programs are executing, they have to deal with the RAM and the address bus and the addressing mode of the computer. So you have different 32, 64-bit, but 64-bit is good for large programs because they need to put a lot of content or data on the primary memory at once are executing. So for modern programs, you usually need to have 64-bit, and 64-bit is advisable for most programs. So I encourage you to install the 64-bit version of your operating system. If you're using Windows 7 or Windows 10, I'll encourage you to install the 64-bit of that operating system if your architecture supports that. So we know we are on 64-bit currently on this operating system. So I'm going to go ahead and download that. So you need to click download, and once you click download, this appears. I don't want to download it because I already have a version I downloaded earlier to make this tutorial a little bit faster and to save time. Cancel. So I'm going to use my own version, the one I downloaded earlier. Um, Here is it, programs, Anaconda. So we are going to install this right now. Okay, so always good to run as admin because it may need to access some valuable resources on your computer, like your drive C or registers and something. So it's always good to run as admin if you're sure of the program, you know it's not a virus or a Trojan horse. Because if you run a virus as admin, sometimes it's very devastating because most Trojan horses or viruses will always want to run as admin when you're installing them, and so they can have root access or administrative access, and they can destroy your computer in just a matter of seconds. So be careful. Sometimes it's not always good to use to grant installation setups admin privilege. So let's continue. Agree. Just me. I want just me because this computer has two users. This particular user is specific only for Python tutorials, while the other user is my normal user where I use to my other stuff on the computer. So just me, and I think the other user has Anaconda installed already. So I don't know, but or I don't know. Let me just say like that. So we're going to continue. Just me, not all users, just me. Yes. So now, note where it installs here. You can copy it, but it's not necessary because we can always find it if you want. So it's going to take 2.9 gigabytes from your hard drive space. So you have to check if you have that amount of space available from your drive C. I have 35 gigabytes free. Wow, just little space. So I need to be careful. So you can continue next. Now Anaconda, like I told you, can you see add Anaconda to my part of environment. This is not recommended. Why? Because um, you don't want to type commands, for example, Visual Studio Code, and it tries to like open that provided by Anaconda. Many stuffs, if you add it to your part, it makes Anaconda get found before previously installed software. You understand? Like if you need to find Visual Studio Code, probably Anaconda may want to present its own version if Anaconda has Visual Studio Code. So it's not good to add it. Even this, I won't add it because I already have Python installed. I don't want to use the Python within Anaconda as my default Python. I want Anaconda to use its Python for itself, not for the system. So I'm going to uncheck this. If you don't have Python on your machine and you don't want to install it, but you want Anaconda to handle all Python stuff for you. You want Anaconda to be your default Python um, interpreter. You understand? You can click that, but I do have Python separately. So you can check the details to just see. It takes quite some time to be honest. So I'm going to sometimes skip part of this installation. So we're going to waste a lot of time. All right, so it's still taking a lot of time. So we just, all right, let's see what's doing. It's installing, it comes with a lot of packages, because it supports data science and other stuff. So it installs a lot of packages like matplotlib, pandas, scipy, all kinds of stuff. You see zip, many all kinds of stuff. So Says here are some of the packages it comes with. A lot of packages, Seaborn, a lot of things, So it's very good though if you're into Matplotlib, you see Matplotlib, H5Py, Bottleneck, NumPy, you saw NumPy, like comes with NumPy, and it comes with a lot of packages, just a lot of packages. So it's just NumPy, Phoenix, um, and all those stuff. So it's very good. So that's why it takes a lot of time in its installation. And I don't know, it looks like it uses the internet to check for updates in packages. IPython, you see, other stuff, a lot of stuff. Qt console, Jupyter notebook, Jupyter server, Jupyter lab, and all those stuff. So does a lot of work, it comes to a lot of Skype, right? So it does a lot of stuff. These are programs developed by a large team, so there's just a lot to them. So I think it's good now. Next, and we are good to go. You see, I don't know what PyCharm had to do with Anaconda, but it looks like they work together. Working with Python and Jupyter Notebook is a breeze with PyCharm Pro. All right, so designed to be used with Anaconda. Download now and have the best data. All right, so they want you to download PyCharm. So we're not going to download PyCharm yet, but if you are a lover of PyCharm, you can download PyCharm. In this tutorials, I'm going to be using Lee clips. Yeah, I just want something raw where you're just free to do whatever you want to do. I believe you can do that with PyCharm, but you can download PyCharm if you like. Okay. I don't want it to open any of this stuff. We good. All right. So we are ready to launch Anaconda, but the first thing is we want to create a desktop shortcut, because like you saw, Anaconda did not create a shortcut. So we need to create one for it. We need to open this, open file location to get the shortcut. So instead of copying and dragging and dropping, which removes it from here, and the system depends on it being here, we can like you see, you can also copy Jupyter Notebook, but I always like to run my Jupyter Notebook from within Anaconda. So let's just use Control C and then Control V, copy paste. All right, so we are good to go. We don't need this. Now let me just check this. All right. So now you open Anaconda and give it some time. Anaconda does a lot of work to start up. Running. I believe these are C programs. It's running in the background, or C++. I need to start different stuffs. Okay, using a bash executable script to do a couple of things. Right, so what we are waiting for Anaconda. Once Anaconda gets loaded up, we are going to only be interested in Jupyter Notebook. Yeah, if you can use R Studio, which is usually for R programming, or Spider, which is for scientific Python development, with GUI, which is to you can use it for graphical stuff and all those stuff. But we are actually interested here is something new, data stuff. Even IBM Watson Studio is very good. It's used for data science, for IBM cloud and stuff like that. If you're familiar with data science using IBM something studio, you can use this. So it's really a good stuff. Anaconda distribution are really, it's a good program. Like you see, it comes with Jupyter, R Studios, um, Spider, and usually sometimes you see PyCharm. You can install PyCharm here. You understand? So, all right. So, like I told you guys, you can install PyCharm and you can install whatever you want from this. So, let's go straight to what we have to do in this video. We're going to start with Jupyter. That's what we're interested in, not Jupyter Lab, Jupyter Notebook. So we have to install it. All right. So let's just wait for the installation to be completed. The following errors occur. They always give this error. I don't know what's wrong. We don't care. Okay. So let's give it some time. I know there's a way to fix that error, but it's not going to affect us right now, so we can move over it. So let's launch Jupyter. Okay, take note, each time you launch Jupyter Notebook, it actually uses your default browser to open. So here is my default browser. Yeah. So by default, Jupyter opens here. Now, to create a new file in Jupyter, what you do is like you go to new, and I have only Python 3 installed on my computer, so I'm going to see Python 3. So new Python 3, it creates a new Jupyter file. All right. Now from here we can start typing our Python scripts. Hello world, like, and run. All right. So now you may want to save this because this stuff have not been saved. You have been saved in some unknown location. You need to know where to save it. So let's save this as. Now it needs you to enter a path. It can be complicated to enter a path here. So what I would advise you to do is this. Now cancel. Instead of doing this, I'll advise you to create. All right. Um, create a folder somewhere, and so I'm going to create a folder here and Python projects, and instead of Eclipse, I'm going to put Jupyter. So new folder. Where is the icon for new folder? Wow, it's not new. It's supposed to be there. All right. So file new folder. All right. Jupyter. All right. We want all our stuff to be here. So what we're going to do now is let's minimize this. Now we're going to open Jupyter. All right, no, here is not. Where's Jupyter? Okay, so in our browser, I want you to take note. Jupyter always opens on the browser. Now what you do next is, rather than this, let's close this. Let's leave. All right, now look what we're going to do now. We can stop this from running. Don't know if there's a way to stop it. I've just forgotten how we stop this from running. Let me check. Log out or stop from running file. Close or halt. Okay, we stopped it from running. It isn't running. Now they just saved it somewhere. This I think this is found in somewhere normally in our computer. This folder, this is where all this stuff is found somewhere. But we are not interested. Let's go to where we want it to be created. Desktop and Python project. No, Python to okay, yeah, Python projects. Jupyter. Now let me check. Let's go back to desktop, and let's go to BT Python. Yeah, that's the place. Projects, then Jupyter. All right. Here is where we want to create um our notebook. So here we're going to use new Python 3. Now here you create a new notebook. It's very easy. Look how it works. Now everything is ready. Now let's save it. You can type print and hello world, right, run it. All right, so let's save this. We're going to use file, save as. All right, it's cool now. Now here we want to save it as. You see they already selected the folder because we opened the folder from here. We opened this folder. So now we're going to write test1. Okay, save. Let's check if we actually saved as test1. All right, so here it was the untitled by default. We can delete this, it's not needed. Now we have test1.ipy notebook, ipython notebook, because Jupyter uses ipython. I don't know whether it's iron python, I don't know, it looks like the short form of iron python. So here is our notebook file. Now we are ready to go. Let me show you something. Let's close Jupyter and open this notebook. Let's go back to the default so I show you. All right, you see, in fact, let's go back to Python. If you go to back to desktop and we click our BTE, you see Python and projects. Now look at Jupyter. You see notebook shows a book. This is a Jupyter notebook file. You can now run it by it's already running. All right, it's already running. You can shut it down here and you can run it now here. Yeah, so very easy. All right, so It's currently running. Now I want to show you how this works. Now Jupyter works in the form of cells. All the cells are like portions of interpreters, like boxes of interpreters or Python interpreters or Python interactive prompts, whatever, but most like Python interpreters. They actually work together. This box is related to this box. All boxes are related together to themselves. When you and their number, Jupyter numbers them for us. If you don't see a number here, no, nothing. This box has not been compiled. Once you see a number, it indicates the box has been compiled. For example, if you make a mistake here and try to compile it, you see there's an error, but it has been compiled. Now, if we can now, all right. So to run a program, a box or a cell. Okay, let's delete all cells first to show you how to create a cell. Let's assume there's no cell. All right, you cannot remove all cells. So let's see. Let's print um, hello. All right, hello world. To create a new cell, you just need to use plus. It's going to be created under the cell. But no, this cell has not been executed. To execute it, you can use run. All right. Automatically, when you use run, a new cell is created under. To cancel, to delete a cell, you click on it and create and just click cancel. So that's it. So these cells are related to each other. What do I mean? Let's say, for example, you have var1 equals to 10, var2 equals to 20, and you try to execute this cell. Let's run this one. Print hello world. Let's run this one. Run. All right. And you try to execute this side. This cell is still linked to this ones. Okay. For example, if you say print var1 and you press run, it prints 10. Just to show you the fact that the cells are separated, it doesn't mean they are not linked to each other. Now, if for example we give a different value to var1 equals to 20, it doesn't affect, and we compile it here. Alright, it doesn't affect var1 here because before here var1 is still 10. You understand? So if you run this now, all right, okay, all right, sorry, it affects var1. So it affects var1. It shows you they're actually linked together. Now let's cancel this and use what happens is if you compile this one. All right, let me show you something. Let me show you what I was trying to do. var1 equals to 20. All right, let's compile this. Now if you okay, let me show you something. Print no, I just want to show you that the cells are all linked together, like just it's like a single Python file. Print var1 20. Now look at something. If you compile this and compile and run this, var1 is 10. Why? Because this one is far behind. You can see it's 8. It's far behind because we had compiled this. So if you compile a cell above, it's always good to compile all the cells or to interpret all the cells below it. And it's possible you can just click on that cell and go to cell. You can write run all below. You see execute it to make everything to be symmetric. So they are very linked together, and you should take note of this because sometimes you may be trying to do something and you come and change a value here, okay, or you check var1 equals 20. Then some maybe you had some statements here doing maybe x equals to 10 raised to the power 2. You forgot to declare a variable called x, and you declared here, and maybe you like okay, or let me say here, let me say here you forgot a variable called x, and you say, oh, I forgot, and I need a variable called y, and y should be 20. Y should be a list of even numbers from 1 to 10. Yes, you say yeah, let me compile this stuff. Yeah. Now you believe your code now has a problem. Why? Because in another cell you actually change the value of var1, and you can't just continue because if now you print var1 is 10. Why is var1 10? Because you had re-executed this cell. So it's always good that if you modify a cell above and you know you used any of the variable down, sometimes it's good to click on this cell, click here, and now execute cells below, run cells here, run all below. Very important. You see now over 1 is 20, everything has been arranged because of this. So I just want to show that these things are all linked together. Don't think they're separate pieces of code. If you fix everything just like one Python file, in fact, you can save it as a single Python file. You understand? So I just want you to have that idea. So what are these in three, in four, and out? All these stuffs. You need to understand that these stuffs are actually helping us to be able to direct someone to a particular line, but they can be printed out. For example, if you just write in three and press enter, you see it shows you what was in three, and look at what was in three. In three was print hello world. You see printed out. You understand now? If you print out, I don't know, was there out three? There was no out three because you saw we have only out 22. So you can print out 22. You see there's out 22. So you can actually print these stores. I just want you to know you can print them. Yes. So even though they're actually labels, you can even print them too. And apart from just having a cell of code, why they call it a notebook is that you can also write HTML code and other kinds of stuffs in here. For example, this you can change this cell from a code cell to a markdown. A markdown is means everything. We can write an HTML. We can use HTML tags here. For example, h1, welcome to Blue Tech Empire. We can h1. We can even say Python tutorials. We can use b. We can now say we can now even use I italics, I Python. I don't know if you can use styles here, but I believe you should be able to use styles. I believe you should be able to use styles. I don't know. I believe you should be able to use styles. Python tutorials. I don't know if you can use color equals to red. Don't know if you can do this. Okay, welcome to Python tutorials. So h1 is a block level element, so the other stuffs go down. Then I'm just trying to show you. You can double click here to change it back to HTML if you want to its normal stuff, and you can do a lot of things. You can use emphasis, and you can even use the code stuff or whatever you want to do. Um, so you can do everything you want to do. I just want you to know you can include HTML along with colors. I've just forgotten how to include colors. Yes, you can include colors. Normally, you normally use a style equals to include colors, but I don't know. Color supposed to work like this, but it might not work. So I don't know. All right, it worked. You see, so you can include colors, color red. All right, so you see, so you can use HTML here, font size. Let me see, font, font. Let's just try to make some HTML. Um, 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 font. We already have italics, so let's just leave it like font size, um, 30 pixel. Let's see this one. All right, so you see, you can do whatever you want to do here, like HTML, and do a lot of stuff. You just need to know yes HTML. So you can even use after this stuff, you can use a break tag to make things to be better. You can use a break tag br to make things to look good. Okay, So you can do any stuff you want. So I just wanted to know that's why it's called Python Notebook. You can form notes together with Python codes on Jupyter Notebook. So it's that's why a lot of people like it for all this stuff. So you can learn how if you know HTML, you can be able. I've just forgotten a lot of this HTML stuff. Like I wanted to write text decoration, I think on something like that. All right, so this is what I was looking for. So all this you can do all this, and if you want. So we are not interested in HTML right here, so let's not waste time on this. You can change this cell back to a code. All right, so I just wanted to show you it's possible to mix HTML with code here. That's why it's called a notebook, because it's not only for Python. Now these cells are linked together. You can do whatever you want to do with them. Like we have been writing programs. Let's try to write more interesting programs, like a program. Let's delete this. Like, all right, let's create a list of items. Uh, let's create a list. All right, let's create a list of items. This program will go through this list of items and call my list mlist. The program will go through and print it and create another list, and new list equals to um, an empty list. I want you to take note, Jupyter Notebook does not have IntelliSense. That's one small disadvantage. You see, you have to type everything on your own. There's no prediction or completion or IntelliSense trying to show you things out. You have to know enough Python to use Jupyter, because you need to be typing stuff on your own. You don't have any prediction, so you can easily make mistakes in variable names and even in the function names. So, for example, let's go on, and I'm going to show you some other things. Let's just finish this program. So, you can use a for x in m list. You can say square is equals to x to square equals to x to next print square. So all right, so you see 416. So here is the program. So we should not waste our time writing all these programs. We are just wanting to know. You can even use a program that actually asks you for your name and your number, like name equals to input. Uh, what what is? You can test any code here like you do on any other Python, like on the Python interpreter or whatever. What is your name? So people actually like Jupyter, because as you see, we don't need to always re-execute our script or cancel all code or stuff. We just code and we go down. We just go down, keep going down. There's no end. So you can always review old code. So Jupyter is very convenient if you're learning. For example, if you're watching a video, this video on a phone, you can be using Jupyter to practice it on your computer, because you just be going down. You don't need to cancel files. You can test pieces of code, and it has coloring and everything. So Jupyter is very convenient for learning or creating Python notes. So it's very convenient. Most times when I'll be doing a lot of tutorials on this channel, I'll be using Jupyter for a lot of the examples. Most times to teach and follow the notes. So we'll be using Jupyter a lot. So you can say what is your name, like id, no uid equals to it needs to be an integer. So we're gonna write input what is your id. All right, so what is your id? I think we are good to go. And then we now print message equals to welcome um welcome somebody. Here is a placeholder. Welcome somebody. Your id is is something. This another placeholder. We are going to fill them up soon. Please visit something for more info. So we're going to use the format. um, Before we fill them, let's create a variable called url and assign it the value the value our website uh, www.bluetechempire.com, and we now see, now we need to fill it. The first value goes for this first placeholder. So we want to say welcome name, so that whatever the user entered as name goes here. Your ID is UID, and URL is visit URL for more info. Like I said, you don't have any intelligence, so you have to try on your own. Print message. So let's see what's happened. Now another way to run a cell is using control shift enter or control enter. So that's what I'm going to be using. Instead of using run, for example, like this, you can use shift enter, or you can use control enter. So anyone you want to use it. So let's use shift enter for this. So it asks me for my name and my ID. Prince, welcome in honor. Your ID is this. Please visit www for more. So perfect. So you can go ahead right now. I just wanted to show you guys. You can, and take note of this. Jupyter behaves somehow like the Python interactive prompt, because if you just write, for example, 2 times 3 and press enter, look what happens. It shows 6. Okay. Now if you write something like product equals to 2 times 3, and you run it, what happens? You see, it does not print it out. So Jupyter behaves like the interactive shell in such a way that if an expression, this is what you call an expression. An expression is something that returns a value, or it has an after effect. That's how they say 2 times 3 returns 6. If you assign it to something, Jupyter will not print it out. If you don't assign it to any variable, Jupyter will print it out. So that if you just create a list, for example, like, and just execute, Jupyter prints it out. Then you say list equals to, and you copy this. You see, it did not print it out. So a lot of these stuff, for example, if you say sort list 1, normally this does not return anything. Is it no list 1 dot sort? Sorry, list 1 dot sort. It does not return any value because it sort the list in place. Normally, I want to know this one. It returns actually none. You understand? If you want to check it, you can write. You can check. Say result with res equals to. You check. If you print out res is none, I think none. This returns none because it actually goes to the list and sort it in place. You understand? So those are just a few things. So now we have seen how to use Jupyter. At least we have understood how the cells are linked to each other. We have seen how a cell you can change a cell from code to markdown, that's HTML, and add notes to your Python script. There isn't much about Jupyter again. If you're here, you can press down to go to the next cell, next cell. If you're on top here and you want to execute cells below, you can go to cells, run above to execute all above, or we get this. All right, so they execute all the cells. So and if you want cells below, you know what to do. You can click it, and this interrupt kernel. You can restart kernel sometimes if you install a new package. Now let's say we want to you can also even import here. Import, you can write any program, for example import OS. You understand? You can even say os.get current working directory and see what it is. So this is just, you can do anything. Now let's see what happens if you need a package and it's not installed. What do you do? For example, we need scrapey. Import scrapey. We get scrapey is not installed. Imported. Let's check something. But I told you Jupyter comes with matplotlib and all those SciPy. So for example, import matplotlib, import SciPy, import numpy. These are all data science stuff. So you see it executed completely. During execution, you see a star here, it executed completely. Now if we need a package and it's not installed, what do we do? Now the way to do it is you have to go to your conda conda environment, go to environment, Okay, go to base and open your command, open a terminal. You understand? From here you can type pip install. One way of doing it is you can still go to the conda. We are not going to do this, but I want to just show you. You can go to the conda command, anaconda. You can go to the anaconda prompt and type conda install whatever package you want, package name. This is the package name. You can put whatever package you want. This is the normal way, but sometimes this way doesn't work, so I want to show you the way that works most of the time. So conda install scrapy. We need a scrapy package. You may need different packages. Everybody, there are lots of packages sometimes you need if you're using this. This is how you do it. So I'm showing you now. Pip install scrapy. We wait. They are going to find it and they're going to install it for us. You need internet connection. Sorry, you have to know this. You need internet connection to, okay, it's collecting everything needed. Yeah, it's cached because I've done this before here for a previous tutorial. So in your own case, it's going to download them. Okay, so your case is going to download most of these stuff. Yeah, so it's installing them now. So this is how you install packages you need. Most of you, if you're going through tutorials online, you're going to see you need some certain packages which you don't have. Now it's installed. Let's close this. Let's go back to our Jupyter. You saw this created an error. Let's try to run it again. You saw executed completely. It means Scrapy is now part of, we can now use Scrapy. You understand? So let's see the kind of what Scrapy has to offer. Let's see the different stuff. So this Scrapy, you see, we can even use help Scrapy to learn more about the Scrapy library if you need it. So you see, Scrapy, web crawling. Scrapy is to crawl the web for all those who are doing what they call data mining. Scrapy is very important. So you see, they say Scrapy is used for this. You know, you can learn a Python package. Python is very good because it documents itself. You see, inherit this. You know, you can learn about something if you have forgotten a bit. So I just wanted to show you this. Now, automatically, when something is too long, Jupyter will go into scroll mode. Usually, sometimes you don't want scroll mode, so you can want to cancel it. So I want to show you how to cancel it now. Go to cell. You see cell type, no, current output, toggle scrolling, toggle scrolling. You see, okay, like this one is too long. It doesn't want to go out of scrolling because let me show you something. Let's try again. I will show you why. Current toggle scrolling. All right, it went out. So you see, you may not want scrolling sometimes. Why? Because sometimes when it shows a scroll bar, you see like this, it's too long. Sometimes you may change the cell to something short and the scroll bar will still be showing. You understand? And you will not want the scroll bar to show. So let me execute this. You see, okay, like now the scroll bar doesn't want to go. So we can change it back to like now the scroll bar doesn't want to go. The scroll bar doesn't want to appear, so we can we can put back the scroll bar. Yes. So I'm just trying to show you guys some tricks you may have problem with. You try it on your own. Now, let me show you some data science examples. So you will complete these tutorials. Now, let's assume. Let me show you. I told you this Jupyter is mostly used for data science. So let's see some data science examples you can have. You can use. So let's start. The first example, we want to draw a simple line plot. So we start by importing. We already have matplotlib. In fact, let me delete this so that you should start like fresh. Import is not from you can say from matplotlib import pyplot as plt, something like that. Or you can say import plotlib dot py plot as plt. Why? Now there's a reason why this as this plt is an alias for pyplot, because in case within your code you need to use pyplot, you always be typing something like pyplot dot something something something. You always, when you want to call a method within the pyplot object or pyplot class, you always used to use. So we usually want a 2-digit or 3-digit shortcut. So that in this case now we use plt dot something rather than pyplot. So you're trying to tell the interpreter that, well, every time I say plt, I'm talking about matplot.pyplot or pyplot. So let's continue. So next, we need to create the x-axis, which is an array of values, for let's just use some examples. Say 55, or let's say 62, let's say 68 instead, or 77, and let's say what, 90 or 88. Okay, then let's create the y-axis. And next we say we can say 1, 5, or let's say 1, 4, and 9 and 16, 23 or 25, maybe 36 can be good, and 49, and maybe 64. So here we have our x and y axis. What do we do with it? We create a figure. The figure represents the whole chart or diagram. You can say figure should be plot. Now we are talking about pie plot. Here we are using the alias figure. Okay. Now next, what do? We create an axis. Now calling figure dot add axis will return what we call an axis. So we create an axis by default. It requires a list, which is usually 0, which needs 4 items. We usually give, say, 0011 by default. It has a meaning, but we're not going to all that right now. So the next step you have is to like type line equals to ax axis. Now this stuff returns an axis which we can use to do further modification. Now we can use the axis to say how the line should be. We want dotted line, so we are going to say it should plot x, y first. Now we say axis dot plot. We got the axis from the figure. Now we are using the axis to plot the graph, and to give some special parameters like this, and to also specify it to have dot dash lines. If you want single lines, we use like this. If you want dash lines, we use like this. There's another one for break lines, but let's not worry about that. So next, we now have to modify the axis a little bit by, let's set the title. You can set the title to say gross effect, and maybe we can set another axis dot set. We have set the title. Now we can set the label for the x-axis is called x label. These are methods of the axis object. We can call it season. And next, we can say a axis dot set. We need to set the y label, and let's call this sales. And let's say next is plt. We can now use plot to show what we have done so far. plt is pyplot. So let's see if we have a mistake. Okay, so here is a simple graph. We see we call the whole figure gross effect here. We call the x-axis, and it's not the x-axis, the y-axis sales, and we call the x-axis season here. And then we just showed we use dotted lines, so you have this line being dotted, and we also use these breakpoints. We use square, so just some small stuff. So and now we can also want to like say, okay, let's see what we can do. We want to create maybe something like a sine wave. It's a common example. We can still, we already have pi. These cells are connected like I told you. So what we need to do now is to install, instead of doing this, we can say, instead of saying import matplotlib again, we already know we have matplotlib, so we can continue by importing In this case, in this example, I need numpy, so we can say numpy, but numpy is too long, so we use an alias called np, which is usually common. You're going to see it in most stuffs. Then we import math because we need to use pi, the pi property of the math module. So we are going to say pi. I think it's an instant. I think it's an instance property or something, or static property or something. Well, so let's look at it. So we will be using the math. Let's import math. What next? I think that's all. So let's create the x-axis for the sign. We will use the numpy arrange um, method or function. We want to create the range starting from this, and we want to end in pi 2 pi. That's 2 pi. I think is 360 because pi is 180. So we say pi times 2. Remember, this is what I was telling you. We are using the pi property of the math module. That's why we needed math. So we say 0.05 intervals of 0.05. NumPy is very good. It helps us a lot. We create variables, and we can carry out operations on those variables within the list rather than using a for loop. So NumPy is very helpful. That's why you can, for example, look at what we're going to do. We can say now y needs to be the sign of all the values in x. We'll just say sign x. If this was a list, you cannot do that. You need to say for x in this thing, create a different loop, a different list which will have the sign of each value in x. But when you're using NumPy, you can just say y equals to NumPy dot the sign of another numpy variable, which is x, and that's all. It signs everything in x and creates a new numpy array called y. So you can see y equals to is supposed to be equals to. So now let's go to the plotting. Plot dot plot. We want to plot it. So we want x is x and y is y. You can use different variable names for this, but we just prefer xy so that we are going to know. Now we say plot dot we need to create the x label. We can see the x label should be angle, and we need to create the y label. You see, so we can see y label, and y label is equals to sign. And lastly, we can now set the title. It's different from setting the title of the figure slightly when you set the title of the plot. You see, the figure on title used to be a bit bigger. Yes. So let's just say plot of title equals to sine wave. I think sine wave, is this correct? Alright, we have an error. Plot dot will not put dot here. Alright, so right here we go. So a simple sine wave. So lastly, I'm going to end with the last example. Let's see how we can plot a bar chart. I want to show you guys how to plot a bar chart, not really an histogram. So we already have our math and plot imported from the above cells. I told you the cells are connected, so we don't need to do that here. We can just continue by creating a figure equals to plot dot figure, and you see, I told you guys now we have to create an axis from the plot. I said this figure dot add axis, and it takes a list with 4 items. We usually say 0 0 1 1, and next we can create some languages. We can say which we want to create a list of languages. We can start from C++. We can go to C. These are some of the languages I learned earlier when I started programming. Starting with C++, Java. Yes, I think Java was the most difficult. Python, followed by PHP. PHP very good too. So these are some of the early languages I learned when I started programming. So we now want to say students who take these languages. We can say For C++, well, many students are afraid of C++, so maybe we can give it 12. C, maybe a little more, 20. What, let's say for Java, people like Java, even though it's difficult. Python, oh, everybody wants to do Python, like 50. And PHP, well, PHP some kind of average 12, 29, 13. Or let's give it 29 people. Yeah, so this case now we're gonna say axis dot bar. Just call the bar. You don't even it needs the x-axis length and needs the y-axis student. You understand? Now we have here plot dot show. All right, so now you have this here is a simple bar chart, so very easy. You can use it for data science, very good for data science. And I want to show you something why people like it too. Again, is you can just export this as a simple HTML document. Maybe you want to show your friends what you've been doing and the small work you've been doing. It's usually very difficult with other IDs, but with this you just need to go to file and go to download as HTML. Okay, it saves the file somewhere and we want to get to that location. We will take it from that location to where we want. Let's paste it here. All right, now let's try to open it. All right, see, this stuff now is independent of Jupyter Notebook. You see, it works. Anybody with an HTML browser can open. As you see, you cannot modify the code here. They've been converted to HTML. So just imagine you can do a lot of work and you can submit your result to your lecturer or your teacher just by converting it to an HTML and sending it to them. So Jupyter Notebook is very good, like to create notes. You can make your own notes from Python function. Like now we can check out in our free time, you can check out the content of the scripting library in our free time. So there's a lot. Secondly, if you have a website, you can write some Python scripts and then just upload it. For example, you can draw this graph from here and just load it as an HTML page on your um on your website. So there's a lot you can use it to teach Python on your website and you have some stuff. So there's a lot you can do with this. So we've seen this. So like I've shown you guys, Jupyter is it's a very good platform for distribution. Like it's like an ID but it runs on a browser. So let's close this. We don't need this again. Close tabs. Um, let's close tabs. So now, if you have Jupyter, I've already taught you. If you want to launch this, you can. I don't know if it has open with. Let's say for example you want to open this notebook. I've already taught you how to do it. Simple. Let's just try it one more time before we end this video. You need to go to home, for example, start your Jupyter, launch it. It launch on your default browser automatically. All right. Go to desktop. We go to BT, we go to Python, we go to projects, and then we go to Jupyter. You see, here is it. Just double click it, app opens, and you have everything. You can edit it now from here. All right, that's all. Here now you can edit stuff. You can edit stuff. You can edit stuff. 30, 30. It works. So print. So print by one. 30. So that's how to use. That's how to get started with Jupyter, both for Python programming and data science. So I think at this point I can say we have come to the end of this video. So see you guys in some other video. See you guys in some other video. Yes. So at least here we learn how to install Jupyter Notebook. Anaconda, and within Anaconda we learn how to also install packages we don't have using the Anaconda shell. And then we also learn how to create Jupyter notebooks and also how to export them as HTML files, which can be very, very important. All right, so that's the end of this video. Okay, all right, see you guys next time later on.